This is lesson 7-5, compare proportional relationships. This lesson jumps really fast into some algebra concepts that relate back to proportional relationships, particularly the constant of proportionality. So I'm just going to go back and talk to you a little bit about that as a review. This is on page 182 in your book, talking about representing proportional relationships in an equation. And the constant of proportionality is the constant multiple that relates proportional quantities x and y. So in order for this to be applied, the quantities have to be proportional. And it's represented as the value of the ratio y divided by x, and it's represented by the letter k. So when we look at the sample that they had up here with a sponge and the amount of water that it takes in liters in a certain number of time, and they had two different quantities for us. We looked at that in terms of a table, and in 10 hours it took in 8 liters, and in 15 hours it took in 12 liters. So to see if these ratios 8/10 and 12/15 are proportional, we set them up, and we always put the y value on top and the x value on the bottom. In other words, y is the first term, x is the second term. And it becomes liters per hour. The constant of proportionality really is nothing more than a unit rate. And again, this is page 182. That's in your other book. So we're just looking to see if these two values are equal. If they are equal, then the ratios are equal. And so you can see here we get 8/10 for both of them. 8/10 of a liter per hour here, 8/10 of a liter per hour here. So this is a proportional relationship. Over here, what we did was we looked at writing the equation that represents a proportional relationship, starting with the k, the constant of proportionality, is equal to y over x. And what we're going to be using mostly today is this equation down here, y is equal to k times x. Now, if you remember, when I want a variable all by itself on one side, what I can do is I can get rid of the other constant or variable that's with it by doing the opposite of what is being done here. So what is being done here is y is being divided by x. And so to undo division, I would multiply, and I'm going to multiply by actually what I want to get rid of. I want to get rid of the x on this side and only have y there. And so I'm going to multiply by x over 1 on both sides, and that's going to cancel these x's. These x's are going to cancel out, and that's just going to leave me with y over 1, which is just y. And over here, I'm going to have x times k, or they wrote it kx. It doesn't matter because it's multiplication. And then all they did was they just moved one expression to the other side of the equal sign and the other expression to the opposite side. So this is the equation that is derived or gotten from this equation that we're going to be using. And we're going to be looking at particularly finding this constant of proportionality and looking at it in terms of this whole equation. So when we have it in this form, we can use the equation to represent the relationship between the time, which was our x value, and the amount of water that filtered through, which was our liters, our y value. So if I want to find how many liters of water does this sponge take in, let's say 32 hours, I simply use the equation and I keep my constant of proportionality because that isn't changing, but I can multiply this by 32 and I can find out that